Projections. The number 2 in my top 10 Aurelius features. This is a query in Aurelius which retrieves a list of T-customer objects, but the difference here is that I'm adding a projection list and asking, okay, bring me customer name and birthday. This selected in the test is a projection. A projection is just a piece of the query expression, which is the field name or expression that you can use to make your query more efficient. In this case here, instead of asking Aurelius to bring my full T customer object, instead I'm asking Aurelius to just bring 2 projections of my T customer, the customer name, the value of property customer name, and the property birthday. And that's the very basic usage of projections. But the interesting thing here is that, for example, you can start to querying using projections. I can use, for example, instead of the regular LINQ order date is greater than a value, whatever, I can compare it to another projection. Shipped date, for example. Then I start to combining those projections. And the interesting thing here is that a projection can generate another projections. If I use code completion, I can see that, let me even delete here, where LINQ order date, and I can use is null, for example, or like, or contains, starts with. I can get the length. I can use lower, for example, to get customer name to lowercase, and a lot of other functions here that I can use to build a query using code completion, and that's already very powerful and flexible. And of course I can use projections to build, to group, to use the equivalent of group by of the SQL statement. Let me build an example here. Bring all T order objects. But get the ship country property and group it. Give it an alias, name it group. And then, for example, count the order IDs. And I can do all these ordered by ship country, for example. Here we have one stats that we created using projections. Here is the number of orders for each country we have in the database. Of course, I have pre-configured the Aurelius dataset here to show data. And we can still experiment with projections. Another example. Instead of grouping by listing the number of orders and grouping by country, I can use, for example, the order date property, the date that the order was issued, and ask for the year projection. Let's group by the year. Since we don't have ship country anymore, we should order by, for example, value, the number of orders. And now we have a different data, which is the number of orders for each year. It's interesting because Aurelius will create the SQL statement for us to extract the year regardless of the syntax, the dialect SQL syntax that for the database we are using it. That's another very nice part of it. We can use the projection, ask for the year of a date, group by, and the specific syntax is up to Aurelius. We can continue, for example, we can ask for, use the same stats, but instead ask for Aurelius, okay, I want this data, but only where the year of the order date is in 97 or 98, for example. And now we have filtered data based on the year of the date time. We have the SQL statement generated here where date part, year is in a specific condition. That's what I said about SQL syntax. And of course we can easily use, we can use data from associated objects to build our query. Let's create an alias here. We are searching for T-order objects, but each order has an order details property that we can create an alias for here. And instead of asking for the query to count the number of orders for each year, we can do a more complex here. For example, the total of amount ordered. Then for that we can ask for the value of unit price times the value of quantity property. Note that the multiplication here is a multiplication of two projections. It is a projection itself. It's a multiplication projection. So if I enclose this between parentheses, I can still perform projection operations on it. So give me the sum of that multiplication, and of course give me that result as value. My mistake, I forgot to use the prefix of order details because I have created the alias order details, because to use the unit price and quantity, which are properties of a T-order detail. They are properties of order detail of each item in the order detail. And there you go, still a different query, which instead of the number of orders for 1998, we have the amount ordered. And again, the TMS Aurelius will convert the object-oriented query into a SQL query. So this is unit price. Note that B is order details table. So B unit price times B quantity, get the sum of it. It does the group by and everything. So it's very flexible, it's very powerful. It just allows you to create a lot of queries like you're doing Pascal, queries in Pascal, and let Aurelius translate that for you. That's a very nice feature. Then of course that's the reason why it's the number 2 of my top 10 Aurelius features. I hope you have enjoyed this feature and all the other TMS Aurelius features. Don't forget to subscribe to our channel TMS Software TV to receive updates, notifications of upcoming videos. Thanks for watching.